So let's review the number sets. These are things that we should have talked about in previous math classes and be really familiar with at this point, but I know sometimes we forget over the summer, or it's not something that we talk about every day, so we just need a quick reminder. So in the math world, right, we can talk about different types of numbers by giving them a set name. So we're talking about things like natural numbers or whole numbers. Okay, and that sort of limits what type of numbers we can be talking about. Okay, so very similar to if you go to the store and you want to buy milk, right? If your parents give you directions and say, hey, go get milk, right? You would need to know more specifically what type of milk. Do we want chocolate milk? Do we want 2% milk? Right, so these number sets sort of give us a more specific view about what types of numbers we might be talking about. So our first grouping of numbers that we have are our natural numbers. Okay, and our natural number set includes things that are our basic counting numbers. So like 1, 2, 3, 4, 5, right? We can do this forever. Our natural numbers are numbers that we can use to count objects. So while it might be silly, we could count 1,000,000 pieces of rice, right? So 1,000,000 is a natural number. We then also have our whole number set. Our whole number set is very similar to our natural number set, except it also allows for us to have nothing to be counted. Okay, so those same counting numbers that we had, but now we can also include the number 0. So it is important to understand here that we have overlapping numbers in multiple sets. Okay, so if I'm just talking about the number 1, it would be the case that 1 is a natural number, but it is also a whole number. Okay, so it can qualify in various different sets. Okay, next on our list is integers. Okay, and integers then allow for our number sets to include negative numbers. So now we can sort of count both directions on a number line. So we can have -2, -1, 0, 1, 2, and that continues out in both directions. Okay, so -10, that works. Okay, any of those sort of positive or negative whole numbers that we previously listed. Okay, rational numbers is the big one that we add next. Okay, and rational numbers has a really fancy definition that we can talk about. Okay, it says any number that can be in the form a over b, where b cannot equal 0. Okay, but what this is really saying is anything that can be a fraction. Now, it might not look like a fraction, it just has to have the potential to be written as a fraction. Okay, so for example, 7 is irrational because I could write that as 7 over 1. 4.5 is rational because I could write that as 4 1/2 or 9 over 2. Okay, so any type of number that can be written as a rational is going to be obviously fractions that are already fractions. Okay, and then any decimal that terminates, which means it ends. Squeezing in there, sorry, or repeats. So repeating decimals count here. 4.7358, right, that ends, so that counts here. Okay, next on our list is going to be our irrational numbers. Irrational numbers are kind of our oddball numbers. Okay, these are numbers that don't end or repeat. They go on forever. They are just weird. Okay, so numbers like pi, right? We approximate it as 3.14, but really it's a number that we can't write down. Okay, it goes on for forever. There's no repeat. There's no end. Okay, this is also true of some of our square roots. So maybe like the square root of 3, the square root of 7, anything that's not a perfect square. That falls into our irrational number sets as well. Okay, then the last sort of things with numbers that we can talk about are our real numbers. And our real numbers are all of the above. Okay, and I tell my students for the most part, anything that you really know at this point before we enter algebra, we're looking at real numbers. Okay, so any of these types of numbers listed up above would count as a real number. Now, when we look at this list, okay, this is a sequential list where once we sort of start, for the most part, it's going to start to overlap other than irrational. Okay, so we have natural, whole, integer, rational, and then we got our oddball irrationals over here. And real encompasses all of that. So if we can find where we want to start in the list, we're then going to include anything underneath it. Okay, so if I say what number set or sets does 17 belong to? Okay, so we'll look up here and we'll find the first place that 17 would belong. So is 17 a natural number? Is it a number we could count to? And the answer to that question is yes. Okay, so once we find where it starts, we then know it's going to incorporate everything underneath it. Okay, so that tells us that 17 is a natural number, a whole number, an integer, a rational, and a real number. Okay, and this is true for any number. So if I talk about something like negative 2/3, okay, so it's not a natural number. Negative 2/3 is not here. It's not a whole number. Negative 2/3 is not an integer, because while negatives are in the integer category, fractions are not. So the first place that fractions show up are in our rational category. So if we want to classify negative 2/3, right, if I'm deciding what set negative 2/3 belongs to, okay, on my list, the first place that it showed up was rational, and I'm going to include everything below, which is just rational and real. So negative 2/3 will be rational, and real. So maybe if we talk about pi, right? Hopefully we realize pi is one of our real numbers, like it's real weird numbers. So it's going to be irrational. And then the only thing below irrational is real.